For Apex, I just wanted to go through these because it created a unique challenge for us. In the first 3 days, we had 10 million unique players. In the first 7 days, we had 25 million unique players and well over 2 million concurrent players in that first week as well. And within the first 28 days, we had 50 million unique players. One of the challenges we had, which was bigger than we had on Titanfall 1 and Titanfall 2, is predicting this and having the server infrastructure to support this. It's incredibly hard when you've got a title that nobody knows about until 2 or 3 days before launch because of a leak, when your marketing strategy is to drop the mic on the same day that the game launches, to understand how many people are going to turn up, and then multiply that by the fact it's a free-to-play game. The only cost of getting in is creating an account. How the hell do you predict? How many servers do you have? How do you know what to have ready for those players? So because of our successful partnership with Multiplay on Titanfall 2, we went with them again for Apex. They do a bare metal scaling into cloud on demand system that we have developed and worked with them over the past couple of years and titles. Our predictions for how many people turned up were wildly out, an order of magnitude. The game was significantly more successful than we ever imagined, which is great. And because of the technology behind it, we were able to scale up and make sure we had servers for those players. Fortunately, we'd also tested to significantly higher numbers with Multiplay on our core systems. So we have a group in EA that's called System Test that we work with very closely before we ship any games. We were working with that team to make sure we did scale testing. We scale tested to 6 million players just in case. So that's not that we expect 6 million to turn up. We hoped 6 million would turn up, but this is for capacity planning, just to make sure we could support that if we needed to. We hit over 2 million, so it was a good test to do. We didn't test to 100,000 and then everything blew up at 150,000. We tested to significantly higher. That was all the core systems. So Strider, Slothy will take you through that, which is a Respawn core system. Marketplace, which is our transactions for people buying stuff in the game, and then Multiplay for their scaling, and then Google for their scaling with Multiplay. So there's two things when we're designing systems. There's the number of peak concurrent players. As I say, we tested to 6 million in our core systems, and everything held up. And it didn't to start with. We had to make adjustments to get to there. But we did that testing before we shipped. And then there's the lifetime players. Both of those were significantly ahead of target. So with the 50 million, we had to scale up some of our databases in the background on the live service. We did that a couple of weeks in on one of the platforms because it was way ahead of what we'd predicted for the first year. So the success of the game created a number of challenges for us. And I'll let Slothy take you through the detail.
So we'll go over the different parties involved. So Respawn has tech called Strider, and that is kind of our loving name for a collection of web technologies that we have. So Strider handles user authentication, parties, matchmaking, some of the monitoring, and our user persistence. And then Multiplay handles scaling up and down our dedicated servers. And we have 3 types of those. We have lobby servers, training servers, and match servers. We also have some voice servers and QoS servers for users to figure out which data center they want to be in. Then there's EA. So for our Origin players, we're hitting EA to do that user authentication. We have the marketplace tech that Fred mentioned for our transactions. And EA has a team that does 24/7 monitoring for our game. So let me walk you through a little bit of how all this works. So we have game clients on our console and PC platforms. They talk to Strider and dedicated servers. Clients don't talk to Marketplace. Strider is our go-between to talk to Marketplace, and our game servers go through Strider to talk to them. So let me talk a little bit about the dedicated servers, because that's the most interesting bit here. So we use a combination of bare metal and multi-cloud. So bare metal is really important to us because it brings your cost way, way down. The multi-cloud is really important for a couple reasons. One is we are now 3 for 3 on game launches running out of servers in the cloud. Also, not every cloud provider is interchangeable. So for instance, yesterday, Apex launched in Korea. Amazon has a Seoul data center that we are using for our Korea launch, but elsewhere, we're mostly hosted in Google. So there's very little upside to tying yourself to one cloud. It's great to be able to use all of them, both for scale and for geographic reasons. So let me walk you through how it actually works in our game. We have one game image. We have 3 configurations of that same executable. So this is the only screen in our game where you're not on a dedicated server. Everywhere else after that, you're on a dedicated server. And one of the reasons is that we don't trust clients, but we mostly trust our own servers. So we want the servers to handle all the really critical stuff like persistence and transactions. So this is what we call the lobby server. It does very little. The first thing you do when you start playing our game is you have to go into training. So our training servers use about a gig of memory, and we have 20 people on them at all times. When someone leaves, we backfill it with someone else. So over time, we have a pretty constant amount of CPU usage. And then after some amount of hours, we will decommission that server and shut it down. And so we'll let people leave on their own, and it kind of trickles down to 0. So once you leave, you'll go back to our lobby. Our lobby uses much less CPU. So once again, we have 128 players at all times on these lobby servers. So we backfill it when people come and go. And it uses about a gig of memory again. And then when you matchmake, so you'll go to our match server, which will pop up in a second, and that one is a different amount of resources. So the important part here is we have 3 different configurations because each use a different amount of resources. Training uses a lot more CPU than lobby. Match uses a lot more RAM and CPU than either one. So we have 3 different ones so that we can maximize our resource utilization on those dedicated servers. So we can run more lobby servers on a box than we can run match servers on a box. And our game, starts at 60 players, goes down to 0, and so over time you have quite a sawtooth pattern on that CPU usage on those servers. There's some music playing. It's exciting.
Oh, no.
Yeah. So just to go over it, we'll do Q&A at the end because there's a lot of stuff here, but 100% of all our game servers are hosted by Multiplay. The scale that we hit on Apex could not have happened without this team. And I want to make sure people understand that it's all real. I'll hand it off to Larry here, who can walk you through their tech. We'll be around at the Q&A.
All right, hi there, everybody. I'm just going to get the slide deck back where it should be. Bear with me one sec. So thanks, John and Fred. It's fantastic to have some insight for our guests into Apex Legends, which has been, in my mind, an unprecedented success. I'm here today to give you a bit of an inside look at how Multiplay's tech was used to enable that success. Before I start, Respawn has stood out over the years by providing a premium player experience for both single and multiplayer. Excuse me. I want to take a moment to say thank you to these guys and to the rest of the teams there and say that Multiplayer is exceptionally honored to be trusted to be part of that experience that Respawn has crafted. So why do we do this? It's not only because we are very passionate about video games, but because playing multiplayer game launches should be boring. Not for your players, obviously. We want them to have an amazing experience. When I say boring, I mean that the last thing you should be worrying about when you launch is server issues. Ultimately, for everyone we work with, your success is our success. Without the awesome games you make, we wouldn't be needed. I'd like to begin this talk with a gesture. I'd like to thank you all for the amazing worlds you've crafted, and thank you for letting us being part of them. That might be a little bit sentimental for a technical talk, but I believe it's important because it's the passion for what we have or what we do that stems from our love of video games, and without that passion, we wouldn't be able to put your players first in quite the same way. So, Multiplayer have been, well, supporting game infrastructure for the past 20 years, or over 20 years now, sorry. And that's coupled with our purpose-built game server orchestration toolset. And when I say purpose-built orchestration, I mean it. Our platform has been iterated on more times than I can count. Each service we provide has been tailored and re-engineered based on years of feedback we've had from our customers. And with over 500 game launches and migrations under our belt, we've learned a few things about getting this right. And we make all of those learnings available to you as part of our ever-evolving platform. And that's not to mention that we're also completely engine agnostic, with global data center coverage and a multi-cloud implementation. We provide flawless launch experiences, although I don't provide flawless speeches apparently, so we'll try a bit harder there. But we provide flawless launch experiences to our customers that scale with the demands of your players. And we deliver a consistent experience no matter what. Now, we understand that multiplayer games are a massive technical undertaking, and they require exceptionally complex solutions to make them work. A game doesn't matter if you can't get past the logon screen. Each part of the overall experience is inextricably linked from end to end. But once you have all those systems working in unison, if your players have nowhere to play, that's a really big issue. Multiplayer service offering is only one part of that overall solution, and I like to say that we bring the end game, because after your players have navigated their way through all of those different systems, we give them somewhere to play. However, I'm always very aware that every element in that solution is an important cog in a larger machine. The fuel for this machine is compute, and we provide scalable compute for video games, wrapped up some pretty cool services and tools. But before I get in that, I would like to define a problem. We think game launches are difficult. Audience participation, please. Can I have a show of hands if you think it's difficult as well? Fantastic. I don't have to explain myself away because some people agreed with me. So basically, for most developers we talk to, player experience is of paramount importance. So how do we deliver that? Especially when you have a few unknown unknowns. In my opinion, it really boils down to, do you have enough capacity available for an indeterminable number of players? Keeping in mind that you have to get that right many months before launch as well. And is that capacity then in the right places geographically? Because players expect a consistent experience which starts off awesome, stays awesome, and just keeps getting better over time. All the time remembering in the back of your mind, there's no second chance for your launch day. Thankfully, and I do say thankfully, we solved some of those issues straight away with our scaling technology. So I'm going to tell you a little bit about that now. We have two models for our scaling offering. One is suited to server browser games. This is reservations. And the other is allocations, which is perfect for matchmakers. I'm going to be doing a deep dive today into how that allocations technology works. Multiplay blend together industry-leading cloud providers with bare metal facilities to provide the most cost-effective and most scalable hosting solution possible. We take the best elements of all the available compute types and we use them for their strengths. That's really important. Basically, we made a super cloud. I think that sounds pretty amazing, but that's just me because I wrote the deck. But more importantly, our API is super easy to use as well. In fact, you only need to use 2 endpoints to scale up. Look at this delicious diagram. I'm going to use my pointer. It's horrible. So I don't want to talk you through a state diagram or anything like that. I'm going to talk you through the individual API calls that are used and what they do. To start, when you want a game server, you call allocate. That literally tells us that you need a game server instance. That call also tells us what region you need it in, what profile you want to use, and the unique ID that you've assigned to that session. It's really important to track that unique ID because you've assigned that to that particular session, and you're going to need it from some of the next steps that we do. And I'm going to keep telling you how important it is throughout this deck, so I'm sorry, not sorry, I'm just going to keep telling you. So once your allocate has been requested, you will receive a status response. This tells us or tells you, sorry, whether your allocate was successful or not. This is one reason why we track that allocation ID and why it's really important for you to track it as well, because upon that successful allocate, you now need to fire a second call to the allocations API with that ID included. That request will return information on that requested allocation that's bonded to that unique ID. That will include the details of the server IP and port, and this is how your matchmaker is going to know where to send players. So that's the how for you guys, but what actually happens when we receive your allocation? Let's take a little bit of a peek behind the curtain. To break this down, I'm going to need to use some pretty diagrams. So to start off, it all revolves around these guys. We have our scaling technology, and we have our multiplayer backend. You send us an allocate, the scaler goes off and confirms that allocation and records the unique associated ID. Then the scaler gives the requester a status. It literally says, yes, I can, or no, I can't. And in the background, we're looking for the best capacity for you to use. So think of the crosshair here as the scaler. It looks for the best place to put your sessions, and it seems that the scaler's found something it likes. But why does it like that particular machine? Well, in order to provide the best possible experience to you and your players, we prioritize bare metal over cloud. Bare metal can help provide that premium experience, and that comes down to the higher clock speeds available in those bare metal machines, that there is just generally more of those bare metal machines available as well. And actually, the amount of bare metal facilities is a big factor here. Multiplayer is in 150 different data centers globally. That means that we're bringing that compute closer to your players. However, cloud is your safety net. It's there to be used when and where you need it, and on demand. But that's not to say in 6 months from now, that story might change. We're always very aware that every game is unique, and they perform differently on each different type of compute. That means we always test every game we work with on all the different types of compute to find what's best suited for that particular title, because we're always ready to adapt so that you guys don't have to. Over the following slides, I'm going to explain one version of our scaling platform. But first, I need to give you a bit of terminology. So let's look here at the anatomy of what we call a piece of capacity. We call this a machine. So what would normally be termed as a server, it gets really complex when you've got game servers, instances, and all these other things. It's a machine. So this applies to both cloud and bare metal. Each machine will support a number of instances. Essentially, these are your game servers. And each instance can be individually controlled via the API. And most importantly, they're all individually monitored as well. And just to give you an example why that's important, if a game server instance is misbehaving, consuming maybe more resources than it should be, rather than impact an entire machine's worth of players, we can remove that misbehaving instance without impacting player experience for the rest of the machine. That's pretty important when you're running games at scale. So I have an example for you now. And in this example, we have 4 machines, 2 of each type of compute, bare metal and cloud. Our scaler and our back-end systems at the top there as well. So we use a buffer system to stay ahead of the curve of player demand. So right now, I don't need one of these cloud machines, so I'm going to put it down into a warm state. So by warm state, I mean we're shutting down the cloud machine, and having that cloud machine in a warm state means that we can react quicker based on player demand. There's no need for provisioning on the fly. We don't need to do additional QA when we bring it back online. It's just waiting to be started back up. Back to the pretty pictures. Right, cool. So the remaining cloud machine is, in this scenario, is going to be left in a hot state. It's ready to receive players. And as we receive allocations, we're always looking to keep machines full. So the red highlight box here shows what we call the hot box. As each instance is allocated, we flag these instances as in use. That's represented here by the green symbols. Now, the allocations are going to keep coming in thick and fast. We've filled one machine, so now we need to move to our next available bare metal machine. Again, prioritizing bare metal first. And that's starting to fill up now, or it should be. Here it goes. And actually, we've started to fill that up so much now that we should really maybe start to think about scaling. However, you'll see on the left-hand side, bare metal machine, that some of those sessions have finished. So we don't need to scale yet. We actually need to backfill those original boxes. So before, again, we touch that cloud, we're going to backfill them. And that's why tracking the unique ID is important. Because actually what you need to do first is deallocate those instances ready for reuse. Now that's all done through the matchmaker. And what we're going to do now is we're going to move the hotbox back. And we're going to retarget for any new allocations that come in the original machine that we were using for those previous sessions. Now, with new allocation requests coming in, we've exhausted our bare metal machines, so it's time to move to our hot cloud. Hot cloud, excellent. More allocations. We're starting to run out of capacity now in that cloud machine, so it's probably time for us to bring up a new cloud machine. We're bringing it back from that warm state, and we do that just in time. We don't do that like hours ahead of time. We don't do that like 15 minutes ahead of time. We're doing that as dynamically and as quickly as possible. All again about trying to maintain a balance between cost and performance. So while I'm talking tech here, I've still had to simplify this explanation, obviously, to make it work with animations and diagrams. There are many scaling factors in play here, and I'm only actually talking about one of them. We look at minimum available servers. We look at the velocity of players entering in, those allocations coming in. We're looking at the previous day's CCU at the current time. And that's just me naming a few of the potential variables that we use to scale. So let me bring down those things. Before I move on to scaling down, I wanted to talk a little bit about continuous scaling as well. So my previous example was only covering 4 machines. But what happens when you need more? Hide them back at the top there, cool. So I mentioned a buffer system earlier. This is probably the best way that I can visualize it. As the bare metal is exhausted, it's released and reused, but we still need to keep creating cloud machines to stay ahead of that unpredictable horde of players. This example here, this is basically what these guys did to us when they launched Apex Legends, because there was just so many players, we just didn't know what to do with them until we scaled up, obviously. And actually, the funny thing here, just to drop some information for you guys, we were scaling up over 3,000 cores per minute at the peak when Apex was launching. I digress a little bit, so back to this bit. The important part here is that we rebalance your available capacity with bare metal machines. This helps us to reduce the dependency on cloud, and we do this for many reasons. Performance and instance density is definitely high on that list, but another is cost, because cloud compute is that premium real estate. Running sustained workloads in the cloud is less effective compared to bare metal, not to mention that cloud bandwidth is pretty expensive as well. So far we've outpaced the horde of enthusiastic players, but now we need to scale back down. Scaling down is usually the hardest part, and with us, actually, it couldn't be more simple. All you need to do is have that unique ID that I've been harping on about that you need to track, and a single API request. Calling a deallocate tells us that you no longer need that game server instance. The importance of tracking that unique ID now becomes very clear, because we just need that, and we can deallocate. And this process also supports multiple fleets, and I'm not really going to dig into the concept of a fleet, but a fleet can be used for dev, QA, and production branches, for example, and this means that you can scale different environments independently depending upon what your needs are. So once your deallocate has been requested, you receive a status response, again, whether it was successful or not, and there's a bunch of messages that tell you why not. Maybe the game session that you tried to deallocate was still in session. We won't let that player experience be impacted unless we need to force it, but we've got methods to do that as well. So I'm going to have another example here. We're going to mass deallocate all of this capacity, and we're going to see the matchmaker sending us deallocates in tandem. Sorry, nearly broke my hand, that was great. So as each instance is deallocated, we're looking to return cloud machines to that warm buffer state. And in my example, we're going to be seeing one of those cloud machines fully deallocate first. This isn't what happens in real-world examples, because you can't control when those sessions are going to finish on a cloud instance over a bare metal one. Games simply just don't work like that. So what we do is we look at the lifespan of every cloud instance, what's happening with the incoming allocations, and make intelligent decisions on whether to allow further allocations on every cloud machine. This means that we can spin down instances more readily. So we have more deallocates coming in, and conveniently, because I made the slides again, the other cloud machine has finished deallocating. So we're going to go bye-bye to that cloud machine as well. So we're starting to deallocate the last remaining instances, moving through the bare metal machines. And now we're down to our last allocations, and actually this is a perfect example of what happens when our zero downtime patching engine comes into play. I'm going to be covering that in a bit. So we've scaled up and we've scaled down. I think it's time for a pretty graph that demonstrates this wonderful scaling system at scale. So this is a scaling test that we did before the launch of Apex Legends, and we ran this test over a 90-minute window. We scaled up to over 230,000 game server instances. That's enough capacity to support over 14 million players. And then we scaled it back down over a 30-minute window. I would like to mention that this was exclusively powered by Google Cloud in a single region. Those guys did us a real solid with quotas that day, because we basically absorbed one entire region. But anyway, that really helped us to prove our tech at scale and just what it's capable of. I mean, I think those graphs are pretty, but I'm a bit of a data geek, so anyway. That gives me a bit of a, like watching it scale up and down so gracefully gives me a bit of a warm, fuzzy feeling. Yeah. But even with that warm, fuzzy feeling, I'm not finished yet. I've mentioned game launches should be boring, operationally at least. And I think being able to reduce the risk of capacity planning takes the first step to being boring. But we can do more. Most multiplayer titles are multi-platform, but how can you handle this from an infrastructure perspective as well? All of our tech has been designed with efficiency in mind. That means making the best use of capacity we bring online for you, and part of that is achieved with multiple profiles. When we integrate a game with our toolkit, we create a template. At its highest level, a template is an encapsulation of all of the settings, variables, hardware requirements, configuration files. Actually, you name it, if it's to do with that game server, it's probably going to be in that template. And once we've made that template, that's our top level. Everything will come from this template now. We then create sub-profiles underneath those templates that allow us to make granular changes to various properties without having to affect that top-level template. So to give an example of this, if each platform uses a different set of command line variables to differentiate itself, I've got PS4, I've got an Xbox, I've got a PC platform, all in command line variables, you can achieve this using profiles, while it's still also inheriting all of the other properties from the top-level template back into that profile. So you can, those real granular changes, real rapid changes as well. So in my example here, I've got one machine running all PC profiles. Up in the top right-hand side here, I've got a little legend, just different colors for different platforms. So rather than needing different compute for each platform, we're able to mix profiles in the same compute. I'm going to just deallocate a couple of those. There we go. So now we've got some allocations coming in for all three platforms. And rather than needing different machines for each platform, we simply allocate them to an existing machine where we have available instances. So not only does this reduce the operational overhead of hosting, you don't have to plan for each platform individually. And it also does something very important. It helps to reduce server fragmentation. It means that you're using the capacity in the most optimal way. You're not got holes all over the place because you're running 3 different fleets or 3 different sets of capacity or however n amount of capacity you need to patch or to do different profiles or different platforms. It's just one set of capacity. Oh, I had an animation there. Missed that. Right, okay. So moving on to patching. More audience participation, please. Does anyone else dislike maintenance windows? 1, 2, 3, 4. I've got enough people that agree with me, that's cool. So I really hate maintenance windows. And in my opinion, session-based games shouldn't have downtime. There should be a method to apply patches live. It's almost like I'm going to tell you that we've got something like that, and I am. So let me show you how we can make patching boring as well. We call this like engine zero downtime patching. Now I have another pretty graph in the background here for you. I told you I'm Data Geek. This is how we do patching in a production level environment. This slide isn't made up. Actually, it's a patch cycle for these lovely gentlemen right here with Apex Legends. And the important note here that I should really make is this is server-side only tech. So what's actually happening here? For simplicity's sake, we're only going to look at one platform, and just the first box here shows a typical day from a global perspective. The little bumps that you see up there, that's when another popular Battle Royale game had some maintenance windows. Anyway, so this is why zero downtime is really important, because you're making sure you keep that premium player experience as the paramount thing in your vision. The second box here is actually showing a zero downtime patch deployment. And up the top right-hand side here, we have 6 different profiles. John already explained they use different profiles for different match types or different lobby, match, and training. So we've got 3 different types of profiles, and we have 2 different groups of those profiles. And this is match B, party B, and training B. The next box that I have here is showing you the actual switchover between profiles. We're moving from the B profile group over to the A profile group. This comes back to our allocations process that we discussed earlier. When you're ready to roll out a patch, all you have to do is change that profile ID. Because actually when your matchmaker's calling, it knows that it needs a different server type. You change that to be linked to a profile, and then when you switch it over, it starts allocating on the other profile instead. So now we can see we've got match A, party A, training A, all running post-deployment, and you can see that they're running with players actively in games. We don't do things in the old way, use old way with air quotes. We don't need additional capacity to roll out patches or to support multiple platforms. We just use what you already have online, further reducing server fragmentation, further reducing cost, and it actually helps to reduce administrative overhead as well, because you don't need to have multiple fleets online per platform. And some people might be thinking, this looks a little bit like downtime. Well, actually, this is the interesting thing, because what you can see here is that Profile B is draining out of machines as matches complete and ramping back up on Profile A at the same time as new matchmaking occurs. And this is happening across 3 different profiles simultaneously. This means that there is no downtime. People have left matches, they've gone back into matches. It's just a seamless transition from one to the other. And another cool thing to mention here is, if you don't have to do a client-side patch, your players won't even know a change has occurred. Actually, you can see here that the player curve restabilizes and follows the trajectory from the previous day. Players saw no impact during this deployment. That's really important. Again, player experience, paramount vision. I love this stuff. So in the scenario where you do have to do a client patch, because we all have to do client patches, right? You just need to constrain your matchmaker to look at the client and server version as a linked set pair, basically. Players finish their matches, they drop out and install the client patch. And because you've mapped those 2 different versions of client and server together, you know what profile to call during an allocate, meaning your players immediately get a new server. And that's going to be on the correct version when they return after patching. You can provide a seamless transition for your players even when you do a client-side patch. So explaining patching, it makes it look super simple, but actually we're doing a whole bunch of other things in the background as well. When we consume the patch data you provide us, which is normally via an S3 bucket or Steam or an SFTP server, we perform a differential analysis against the previous game image. We take only the changes between the game image and we build a diff. That diff becomes part of the profile it was deployed to. And then we push that to all of our global mirror nodes. Now, I think in my illustration here, I've got 7. We have 170 of these across the globe. And after we've pushed to all those mirror nodes, our install manager then deploys each profile in parallel to the existing profile, again, using the same capacity. No additional fleet, no additional, whatever you want to call it, we're just doing it in the same capacity. And apparently I've just skipped ahead in my own notes, but there we go. So this isn't just about saving you money. Sometimes it's just about doing things in the best way possible. And this system not only helps to streamline deployments, reduce bandwidth usage, and make management of live services easier, it's another step towards a better player experience. You might be thinking at this point, all of this sounds pretty cool, at least I hope so, but it must be really hard to implement. Thankfully not. In fact, we work with you from the beginning to integrate your game into our platform. There's no SDK required. We just need a couple of simple things to get started. We need a copy of your compiled game server binary and any associated files. That binary needs to support the binding of server IP, port, and configuration path at the command line. And the final real nice to have is the ability to query that game session state. It is actually quite simple. So hopefully by now, you're the right type of board, not of me talking, I hope, but thinking of all the time and headaches you can save by utilizing a system like ours. So let's review. The unpredictable horde of players just became a little less scary, right? Or at least, I hope so. Show of hands, less scary? Some people agree with me, I'm enjoying that. So we scale servers and we just keep scaling as your players demand it. We keep everyone happy. We've reduced server fragmentation by default. We've made patching a breeze. And hopefully I've given you more insight into our platform than we've ever shared before. And to be honest, there's so much more I could tell you. Let's quickly, very quickly, look at some of those other services as well. We have a great logging system that collects and centralizes crash dumps, server logs, and anything else that you want us to collect from disk. A pretty sweet monitoring platform that can query live game sessions as well. And this is super important for optimal scaling and health recovery. I don't have time to talk about that now, unfortunately. And most importantly for me, I came from a tech background. I used to be an IT manager for a nuclear engineering company. And having a 24/7 live operations team looking after stuff for me would have been a godsend. I didn't have that. I had 2 guys and me. So this team can make your lives so boring that you might even be able to get some sleep at night, because I know that a lot of developers work round the clock, so we want to let you sleep. That's what I'm trying to say here. So we've mentioned matchmakers as well now several times, and it almost seems like Multiplay should have one. Very soon, Multiplay are going to be having a matchmaker. And we've been working very closely with the Unity Connected Games team and Google. And we're in the process of building that matchmaker. It's not done yet. We are close. But what's special about it is that it's game engine agnostic, just like every other service that Multiplay provides. So I'm very happy to announce Multiplay matchmaking. Sort of. It's not done yet. Soon. So I've always been told to end on a positive note, but I'm a cynical Brit, so it's quite difficult for me. But if you are interested in talking with Multiplay about your upcoming titles, maybe you want to find out more about Query that I kind of just dropped there and didn't explain, or anything else that I've talked about today, you can either come and catch one of us at the Unity stand, or I do have some delightful colleagues over there in the background that are willing to have a chat with you. And this motley crew has helped some studios and some developers, big and small. A couple of them have assisted with some of the biggest games in the world. And one of them, this guy up here, that I've made into a lovely little legend right there, might even be an Apex legend himself. I would say that I'm embarrassing them, but they are salespeople after all. I'm just giving their egos, well, making them even bigger with every bit of screen time I'm giving them, so bye-bye. And with that, I'd like to thank you for listening, and I believe we have a few minutes left, and John and Fred and I would be really happy to take any questions you might have. Thank you.
So I have a question for you. That makes a lot of sense from scaling up your game instances. Did you have any trouble scaling up or with your matchmaker handling that scale as people are or either matchmaker or lobby with people logging in?
I think that's come over here.
Yeah, absolutely. Part of the scaling was to get Strider to be faster, and a lot of that ends up being on the matchmaker. So one of the things we do to help with fragmentation is for every match, we allocate and deallocate the server at the beginning and end of it, and that gives Multiplay a chance to defragment us and shut down some of our more expensive hosting and move us to bare metal when basically it helps your downturn. And so we're doing a lot of calls into Multiplay, and when you have 2 million people concurrent, there's many thousands of matches getting created every minute. And so some of it was Mike Kalis, who's one of our engineers who spent a while trying to scale up our matchmaker specifically.
Thank you.
I had two questions for Multiplay. The first is around orchestrating the bare metal and the cloud infrastructure. Is that a set algorithm for all your customers, or is that configurable by customer or any other metric?
So I think the question here is, do we do multi-tenancy? Would that be a fair synopsis?
Sort of. Just curious, like how you decide how to change it up where it's 80% bare metal versus like 20% cloud. How does that decision made?
I get you. So essentially, that all comes down to each individual game being unique. We make sure that we do an evaluation process. It's one of the things I didn't really explain today is how we actually integrate with our platform. But actually, we take that compiled game server binary and we do an evaluation around it. We look what makes it tick, and then we look how many instances we can place on both bare metal and on cloud. Once we've figured that out, we can start to look at actually what bandwidth usage is there. Can we do a play test with the customer? We can start to see what those real-world metrics look like, and then we can start to decide, is it a game that's really, really bandwidth intensive? We probably want to use more bare metal for that because it reduces the cost of that bandwidth overall. Or is it something that could be more cloud heavy? And then we can use those splits. It normally hits about a 70-30 split at minimum, but I've seen games go up to 90-95% bare metal, 5% cloud. Does that answer your question?
Yeah.
You
And
had
then
another
I have
one.
a second one, yeah. So when we talked about the zero downtime patching, I wasn't really clear how you were switching between A and B. Is it all installed on like the same machine and then just switched over?
Yeah, so that install manager piece that I mentioned at the end there where we create those diff packages, when you deploy into individual profiles, that's why you have an A and a B type. I think before you guys have had like A through F at one point as well. It all depends on that. So you install into A, you install into the new version into B, and maybe you have a C as well. What happens there is once those profiles have been created, they get installed in parallel in the existing capacity. So I've got my bare metal machine. I now have 3 versions of that game running and installed. We spin up the cloud as those patches are deployed. We install the game in parallel, and we put it back down into a warm buffer state again. The reason why we do that is we want to be ready when you want to scale up. So we're doing all of that in the background, but then when you switch on the matchmaker to go, I want this profile instead of that profile, we're not killing those original games. We're letting them play out and finish, and then we're scaling back up. We'll clip the mic. We're scaling back up again to actually go on to that new profile. Does that make sense?
Yes, perfect, thank you.
Awesome. We have 5 minutes left.
Oh, okay.
15 minutes left. Wow, we were fast. Okay,
I have 2 questions then.
crack on.
You were mentioning bare metal servers a fair bit. Could you elaborate a bit on what those are? I mean, are they
Yep.
like literal dedicated servers that you rent, or do you like co-locate space?
It's a bit of both. So it's literally, we will go out to many different data center providers, and we do a very large security vetting piece against them. We make sure that they work, they don't mess around with UDP packets, they're going to be a good fit to be part of our global network of providers. And then we lease server hardware from them as well. And then by that, we then put our technology on top of it, and then we make it available for all of our customers. But it's always their own capacity. So we're not sharing capacity amongst many, many different customers. Whatever solution we provide is just for that particular customer.
Makes sense. Another question, I guess somewhat related. If our services are already running on like Kubernetes or something, and we were looking at like say AKS or EKS for supporting them, is there like a significant jump between that and what Multiplay supports, or are those services kind of comparable?
It depends on what that game server binary is running inside those containers. If it's not required to run inside a container, then definitely, yes, we could have a look at it and we can do that evaluation piece and do that work for you. Essentially, like we do the exploration about how to import that into our system. But if they are inextricably linked, then it is more work on the development side to figure out how to extract it from that service.
Okay.
I should mention, we don't do any hypervisors, we don't do any containers. It's all direct OS access. And then from the cloud, obviously, you've got a hypervisor there, but we can't get away with it because that's cloud. Cool.
Hi, thanks for the talk. So I've got two questions for you.
Sure.
So one is, how do you manage geolocation and latency reduction?
Geolocation latency reduction?
Yeah.
Okay, so that is where we use our quality of service nodes. It's something that we're actually building on right now. It's something that the Respawn guys use at the moment. When we have players come in via the client, they do a scan to those quads nodes to look for the best location to put them in. So it's not so much we have to deal with it in the back end, we're actually dealing with it at the front end to make sure that players get to the right place that they should be going.
Yeah.
Does that make sense?
Yeah, that's perfect. And the other question is, what operating systems do you support?
What would you like?
So like Ubuntu and Windows?
Indeed. Yeah.
Perfect.
So we're completely OS agnostic as well. We prefer to support Ubuntu and CentOS and also Windows. I think it's from 2012 to 2019 now. No, 2016, sorry. We're not quite on 2019 yet. But to be honest, if we need to be flexible, because every game is different, like I've already said a couple of times now, we can find a way of making that happen. That's the differentiator, I think, for multiplayer, is that we're invested in being consultative rather than just going, fit in this box, please. No, we want to delve into what you need and figure out a solution for you.
Perfect, thank you.
Awesome.
Thanks for the great talk.
Thank you.
I have one question. You said that you use a multi-cloud solution. How does that fit with, for instance, Amazon's global accelerator to be able to play with players all over the world, not just within one region?
So the compute that we use when it comes to cloud providers is something like your EC2 or your equivalent from a GCP, like Google Compute instances. We don't tie into any of the platform-specific functions that are available from like AWS or GCP. We're just using the raw compute. Does that answer the question?
Yeah, sure.
Thank you.
Thanks.
Hello there.
This is probably one you can't answer, but who do we talk to about cost?
I can answer that. So actually, one of the gentlemen I can see sat in the background there, that is the Apex legend, by the way, from the multiplayer side of things. Yeah, stand up. Do a dance. No. Okay. So actually, yeah, we have one of our colleagues here. He is one of our, actually, is it head of EMEA sales now? Yes. Yeah, he recently promoted, so we've got to give him his props while he's like fresh. But anyway, yeah, he is the commercial guy. I'm the tech guy. We are a dynamic duo of sorts. But actually, we can work together to actually look at what you need to do and then give costs like that. If you're looking for a specific cost of like how much does it cost to get started, it depends what region you want to be in. It depends what your game server does. What I can say is, if it's something like Europe, and you're going to put up one game server there, and you're going to put up one game server in America, and then you're just going to scale, the base cost there is going to be about $1,000.
All right, awesome.
Roughly. But roughly.
Thank you.
Hello.
Hello there.
I had a question about the Quas nodes you're talking about, and whether that was something specialized or if they were just simplified game servers that just serve pings or something, and how you decide between running a specialized set of nodes for that versus, for example, just pinging spreading the load across all of your running game servers, just from all your players, just to spread the load.
Yeah. The Quas stuff is more about we have a network of our own quad servers. I think you guys have your own specific quads nodes that we've designed and built out a solution for Respawn specifically. We do have a shared version of it. I think it's one of the only sort of multi-tenant versions of the product we offer. But if you were to ping all of your individual game nodes, where are you going to collect that back to? And then where are you going to aggregate that back to the matchmaker? Having one server that is collecting all of that information for one geography in one region, feeding that back, means that you can get much better or much quicker response times. And also the matchmaker has a more intelligent path to know where to go. Does that make sense?
Yeah, in my experience, we had like the clients would do the pinging, and then therefore just when they're signing up for matchmaking, report the pings to their regions.
Would you like to take this one, John? This seems very much in your wheelhouse.
Sure. Yeah, no, that sounds about right. So we basically have a glorified UDP echo is what those quad servers are. So we have the clients do a series of basically pings to each one, and then they look at packet loss and latency to each one and kind of build a preferred list. They send that list to Strider, so when we're matchmaking, we know what the client best to worst preferences are. So what it means is you're not always guaranteed to play in the best data center, because it kind of depends on, might be a bare metal data center, and we might be full. So we take those and group them into regions. So in every region, it has to be backed by cloud, and ideally it starts with bare metal and then scales up into cloud. So that's kind of how we do it, is it's a preferred list, but we roughly look at it and figure out what's the best fit for the matches we're making right now.
Okay. One quick follow-up. Do you run like a fixed number of these nodes per region kind of thing, and is that enough to handle the load of all these pings?
Every data center has its own quad server. You can actually, in Apex at the main menu, if you sit and wait, you'll see an option to look at our data center list, and you can pull that up and see how many we're pinging, and what the latency and packet loss are to each one.
Have you guys had to integrate any DDoS protection solutions at all?
So depending on which facility we run the capacity out of, we have DDoS protection for some of those sites. I think a lot of the sites that Respawn are using have that protection just as standards, just by default. We don't have to build anything out specific. We just make sure that the facilities that we're using provides that level of protection.
One of the things that we learnt on Titanfall 2 as well is that cloud is very good at DDoS protection. We had a number of attacks into bare metal data centers on Titanfall 2 in central US, and we had 2 data centers. They attacked us in one. We moved the capacity in the multiplay system to the second bare metal data center. They followed us, and then we moved it into cloud, and then they lost us. So if we get an attack, and they happen from time to time, we move capacity into cloud very quickly. It became a one-button solution after this happened in Titanfall 2. So we move into cloud, and then wait for it to die down, and then bring everything back. We've had a couple of those on Apex in the last 6 weeks. We've moved the capacity, moved it back a few hours later. Just works.
Yeah, and actually that used to be part of my old sales deck. We used to talk about that exact scenario where one bare metal facility was attacked, the capacity was migrated, and then we went up to cloud. Exactly what Fred's just explained. But the real important thing here is actually that migration of the workload is transparent to players. And that's why we have so many data centers globally as well. So rather than we have one US West location, I think we have 5. And that's for bare metal, plus 2 cloud providers as well. And you get that whack-a-mole situation. It's like, come and chase us. We're just going to keep jumping around, moving that capacity around, making sure to keep that player experience really premium, and not letting these people rain on everyone's joy and parade.
With the cloud DDoS protection, are those extra services you pay for, or is it just by default with those servers?
No, we don't have a specific cloud DDoS protection solution. It's just the way that the cloud providers operate that absorb that DDoS.
Okay, thank you.
5 minutes.
It's me again.
Hello.
You said that you like to get hold of a binary so you can do testing and play tests and stuff like that.
Yep.
Generally speaking, how early do you like to get that?
The earlier the better. I think we worked with you guys for 2 years, nearly. Yeah. But the worst case scenario is we've seen someone send us a binary 4 hours after they've launched.
Okay.
That was a pretty special evening. But we can get those sort of integrations done if it really matters. And we're not talking that you have to be one of the giants to make that happen. We did that for an indie studio that were blowing up, and they were like, we're in pain, please help us. And we were like, hi, how can we help? And we did it, we integrated them, we brought up additional capacity for them in the background, and just made it happen for them. Their players were happy, and then we took the time to make sure that they were integrated properly, and then we stepped down the cloud servers that we'd spun up for them. We brought in bare metal to underpin that whole solution, and then we integrated them into the scaling platform so that they could just go up and down gracefully.
Awesome. Thank you.
Let me jump in. I'll flip it around and say, how late do you want to start testing what the game will be like when it's shipped? So we do all of our internal playtests on multiplayer servers. And what's great is we can run a playtest where our studio is in LA. We can do a playtest on West Coast servers, East Coast servers. We can move it around. We've done playtests in Europe. And that gave us the easy ability to try all sorts of different high latency, try different things and make sure that we're testing the game long before it ships.
Yeah, I have a few questions. So I guess if at any point someone else has a question, feel free to come up here and just interrupt me.
2.5 minutes, is that right?
So when you guys provision either the bare metal machines or the cloud machines, do you usually aim to be able to handle all the instances when they're running in worst case scenario, or do you try to kind of assume that they're going to be running at some capacity that not all of them are running at max?
Actually, we're looking for all of them running at max, because if you don't look at that case, you could negatively impact player performance once you do have a full server. Remember, we're always looking to keep boxes full, because that's the best utilization of the capacity. So if you target, like, we might have 3 out of 4 potential allocated instances, as soon as that 4th one hits, everyone gets annoyed because they're getting a poor player experience. Does that make sense?
Yeah, and I guess to follow up on that, when the game first launched, there was rare cases where you would join and the server felt like for multiple people it was running in slow motion, where essentially like every frame you would see your client-side prediction roll back a little bit. Mm-hmm. First of all, it was cool because if that happens in Battlefield, it's super haphazard, and this was like consistent. And I was curious, I guess, like on the engineering side, what was that? Was that an oversubscription on the cloud, or was it something, if you're allowed to go over that?
No, I'm happy to. So we are still investigating that one. There's an engineer back at the office right now digging in. That one is not a case of an oversubscribed box as far as we can tell. So what it is so far is our game is very main thread bound on the server because there's only so much you can parallelize. Mm-hmm. And it looks like there is some weird case there where we have slow something, and we are still trying to track down exactly what is getting slow in those cases so we can quickly fix it once we can determine that.
I haven't noticed it much at all lately, so I just assumed you guys figured something out.
I appreciate your confidence. We will.
And I guess a general question, how much for, I guess, your networking side of Titanfall and Apex, how much latency compensation do you do for motion? Like, for example, when I see another player, is that something that you try to compensate for where they would have been if we were sitting in LAN, or is there like interpolation and just, they're still somewhat in the past?
Yeah. So, wow, I'm going to do an FPS networking talk at some point this year. This is a good one. So when we are playing back, we're interpolating between 2 snapshots on the client. And when you fire that bullet, the server finds those same 2 snapshots that we sent you and interpolates the same amount between them to do the bullet tests. And so if it's all working correctly, it should be perfect anti-lag, bullet collision. And so there's that one is I can go 2 hours on that topic.
Cool. But yeah, I think, but that one, correct me if I'm wrong, that assumes that you are still seeing other players in the past, but basically whenever the server checks against it, it checks against that same timestamp. It's the whole rollback and then check mechanic, right?
Absolutely correct.
Cool. So you guys don't do any kind of extrapolation to... Cool.
No, extrapolation is always bad.
Yeah. Unless you're racing, right? Or...
I've never done a racing game, so yeah, that one sounds even harder.
I think that we're being told that we're done, right?
Okay.
Cool. Thank you very much, everyone. We really appreciate it.